Good evening, everybody. I'm the last one of the day, so I hope it will not be too boring. So the main topic of this presentation is the quality controlling cables. It's a topic that's becoming every year more relevant since we're receiving more input from the clients when we talk about quality control. First of all, we have to understand what does quality mean. There are basically three characteristics that we have to consider when we talk about a quality cable. First of all is the reliability, so the ability that the product has to work over a certain period of time. There is the compliance of the cable to the relevant standard, and there is the consistency of the cable quality between different production batches and manufacturing years. There are basically two approaches when we talk about quality. The first one that was very popular in the past was the reputation. So you have to buy a product and you just go to either a manufacturer that you know or you had a good experience, or for somebody who's like highly recommended in the market. Nowadays the things have been changed a bit for many reasons. Interest in diversifying the suppliers, the interest of approaching new suppliers, maybe cheaper supplier, and this is where the testing has become really important. So, quality. What is the client actually looking for? 20% of the client, as an average, they're looking for a good product. The 80% are just looking for a product that's supported by enough paperwork in order to waive any liability in case there is an issue. When I was working in Italy, finally Italy had a regulation on fire-resistant cable for fire alarm application, and due to our experience we decided to have a certified product. We're one of the two manufacturers in the market with a certified product. When I went to one of the distributors and I showed him the certification, he said me clearly, I don't actually care about your certification. What I care is that if there is any problem, you will be liable for it. So that's how unfortunate the approach sometimes is when we talk about quality. So the main tools that we have when a manufacturer has to guarantee the quality is either the declaration of conformity, an internal test with the presence of a third-party inspector or a client representative, and finally the product certification. So the declaration of conformity is just a written declaration where the manufacturer guarantees the compliance with the standard. So there is no test performed, there is no test report that can be issued. Usually you agree for a declaration of conformity, and then when you submit the declaration of conformity, the client asks for the test report. This is two different things. If it's just a declaration of conformity, a declaration from the manufacturer is enough. How you can be sure about the performance? You should trust the manufacturer. The second option is the test report. So an internal test is performed in the factory with no supervision of the client or a third-party entity. The results are recorded and the test report is issued. Again, there is no guarantee that the result of the test report are genuine because there is no supervision. So there should be trust in the manufacturer. The next step that's very common nowadays is to have the inspector witnessed by a third-party inspector. So the process is exactly the same that we mentioned before, but there will be somebody who's independent, who's coming from a reputable inspection company, who will just guarantee that the process is going on flawlessly, so that the procedures are correct, that everything is set up properly, that the actual results are recorded into the test report, and at the end the third-party inspector will just stamp the certificate saying approving the results. Another step is the independent testing. Instead of performing the test in-house, the samples are given to a testing laboratory who will perform the test and issue a certificate. This is useful in few cases. One is if you don't have an equipped test lab, or when maybe there are like very specific tests that's not economically viable to have the equipment to perform in-house, or when the client prefers not to have the manufacturer involved in any case. So when the test sample has been submitted to the testing laboratory, the manufacturer has no control on the output. So we get notified if the result was positive or negative. And at the end, we have the product certification. That's the most complicated of the quality assurance procedure. So the manufacturer submits a product for a certification, and the certification body has to define which are the procedure and the requirement in order to issue the certificate. It's not usually enough to perform one test, but more tests are required. Usually tests on different samples are required in order to cover an entire range, maybe different cross sizes or different number of elements. When the tests are performed with a positive result, the certification is obtained, and the manufacturer can use the logo and the certification name on his products and marketing material. But the process is not over. There is all the renewal and surveillance part. Surveillance means that there are like regular inspection to the factory, that samples are taken from the factory or from the market, and the certification body guarantee that even during the product life, the quality is guaranteed. If there is a major failure, the certification body can require to withdraw the certification on the product. So, certification is a complicated thing. It's suitable for standard products that are produced and sold regularly in the market over years. They're absolutely not appropriate for custom-made products, products that are made according to project specs or for a production that is limited in time. Typical example is the oil and gas sector, where every project has its own specs. Going for a certification on this product is not the right way to go. First of all, because this is not the meaning of the certification. Second, because it's an expensive procedure that takes a lot of time. Can take, I believe, an average of 2 months to 6 months. So definitely this is not appropriate for a special project. Another important thing is to check what the certification is about. There can be 2 products certified by the same lab according to 2 different standards. So it's not enough to say I want a CESI certified product or a KIMA certified product. You need to say what, according to which standard. Then we talk a bit about the testing. Basically, the testing of the cables can be divided in 2 categories. One is the type test. That is usually a special test that is required to verify the compliance with the requirement. And the routine test, that's a standard process that's usually into the factory to guarantee the quality of the product. So the purpose of the type test is to prove the design capability, not to prove the regular functioning of the product. They're usually conducted on representative samples. Representative means a sample that's characteristics for the application. Can either be the smallest of the family, the biggest of the family. This depends on each product and on the experience of who's conducting the test. When you do the type test, not the single product that you tested is covered, but all a family of products that are similar to these, that fall into the same type. They're often destructive, so you cannot ask to have the entire production tested, because the entire production will be scrapped. And they can perform either in the factory or in an external lab. The criticality of the type test. It's very important to agree with the client what are their requirements before starting with the type test process, because a clear understanding will save a lot of effort during the process. First of all, it's important to define the type. So out of an entire order, in how many families we can divide the supply, in order to just do the number of tests that's required and avoid repeating non-necessary tests. At the moment, for a client, we are doing a test on an outer jacket of the cable. These are 9 cables that have the same material for the outer jacket, but the customer requested to have all the cable tested. So we're conducting the same test 9 times. The client wants this, he will pay for this, it's not a problem, but I have to tell him we're using the same material. The output of this test will be the same. Another important thing is just to agree with the client if a type test from a previous supply can be acceptable. Most of the time, the cable have similar construction, so maybe a test that I've conducted 1 year ago using the same material can be applicable to this supply as well. Another important thing is to understand what are the features that characterize a certain performance. Let's make an example of 2 cables, an armor cable with low smoke zero halogen outer sheet, one with mica XLP insulation and the other one with normal XLP insulation. If we do a flame propagation of these 2 tests, the output will be absolutely the same because the only difference between the 2 cables is the mica on the conductor. So, yes, in theory, these are 2 families. One is fire resistant and the other one is flame retardant. But, you know, discussing with the client, we can make him understand that maybe just performing 1 test is enough to categorize both products. And another important thing is to carefully select the samples and number of tests to be performed. Some tests require really a lot of effort to be performed, a lot of meters of cable that need to be scrapped. So selecting wisely which cable of the family can be tested may reduce the test preparation and the meters of cable that we have to scrap. The routine tests are the daily activity of quality control that we perform in the company. Their main purpose is to detect a faulty product, and they're usually performed either during the production or at the end of the production on the finished product. They need to be performed on each batch. They're not destructive, and they can either be performed on 100% of the production or just on some samples. What's very important is the FAT procedure. So whenever we do a test, there are the procedures that usually are defined by the standard, and these procedures need to be correct and need to be supervised by the third-party inspector or the client representative. Because if we use a procedure that's not a relevant one or it's not correct, the cable can be, the result can be non-significant. And this can be also a trick used to easily pass the test. You know, if we do a fire-resistant cable but we don't apply the power to the cable, we'll not be able to test if there is a short circuit or not. So this is the example of a misleading information. This is a data sheet from a cable manufacturer. We see here that's mentioned IC 60502, 061 kV. Again, 061 kV is mentioned here. But when you look at the test voltage core to core and core to screen, it's only 2000 volt. Even if IC 60502 prescribed the testing at 3500 core to core, and not 2000. 2000 volt is for the 500 volt cable. So this is a case in which it's definitely we're using a non-correct approach to the quality control. And another thing that we can notice is that this cable is approved by a very reliable third-party lab. And so when I discussed with the client and made him notice this, he said, but this is an approved cable. Be careful. If you look at the certificate of this cable, it's not referred to the voltage rating. It's just the certificate on the fire performance of the cable. So even if a cable is an approved cable, the approval just certify what are the aspects included in the certification process, not the other aspects. So I can have a perfectly certified cable for the fire resistance and then just put a lot of false information about the other aspects. Or again, this is actually a test report. It's like smoke density rating according to the 2834. And the results are really good, like 20%, it was like the limit, and the result obtained was 14%. But if you notice, the test has been performed only on the inner and outer sheet of a LSZH cable, where the standard clearly prescribed that the test need to be performed on the entire cable, not only on the outer sheet. So these are 2 cases in which playing with the FAT procedure will allow to issue positive results, even if maybe the quality of the product is not that high. What's also very important is that behind the test report, the test certificate, there is a lab. So the factory owns his own lab where is he performing the test. He's checking, you know, the production, and he's also doing some, you know, third-party inspection with the client. A third-party lab, an equipped lab is important because, first of all, you can invite your customer to just to check the performance of the product, because you can monitor frequently what are the performances. Sending the samples for third party is something that takes time. It's usually expensive. If you have an in-house lab, you can do it whenever you have time. Whenever we're not performing a test for a client, we just usually do one of our internal tests. So we always have some tests going on that will allow us to monitor the quality. Definitely an inside lab will support the R&D department whenever new products are, you know, brought in or new materials have to be tested. And first of all, it will improve the quality culture within the company. We try to bring all our new joiners for a certain period of time in the lab where they can actually see what are the problems related to cables. We invite the customers to attend, we invite the suppliers to see our lab, and I believe that this is the way in which really the quality can be perceived and can be understood. Thank you so much.